All right, guys, we are going to go ahead and finish up this practice test. We left off at question number 37. So let's dive right into it. This says a function f is given. Select terms to describe the end behavior of the function. So when we look at this graph, we know from, you can look at your reference sheet over here for number 37. And we can see the form that this is written in. Ax squared plus bx plus c is our standard form of a quadratic function. So what does a quadratic function look like? Is it looks like an n or a u. This 20 would be your y-intercept, and we know that this right here, this f of x equals ax squared plus bx plus c. That c right there, that's your y-intercept, which we don't really need for end behavior. But this letter A right here tells us that if it's positive, then our graph looks like a U. If it's negative, then we know that it's like this lowercase n. So we know, however our graph goes, whether it's over this way or over the other way, and my y-intercept is definitely wrong because that's down in the negative, but it doesn't matter for this. What matters is that we have something going up like this. So our end behavior says that as the x values are approaching negative infinity, what is f of x? And f of x is your y. What is y approaching? And your y's, it's going up to positive infinity. And over here, as x approaches positive infinity, your y's approaches also positive infinity. And I didn't really see anything for end behavior to practice in IXL, but we can go ahead and enter that. Positive infinity and positive infinity. That's all we needed to know to be able to answer that question. And only 12% of students got that right. What do you think kids picked that almost everybody got this question wrong? What did they put? Ooh, where's my calculator? There's my calculator. Calculator small, questions big. Okay. Yeah, what were kids thinking here? I don't know. Did they just like never see a question asked about end behavior before? I'm not sure. The next question, number 38, says the expression the cube root of 18 times 5 cube root of 6 is equivalent to 15 cube root of what? What is the value of x? Well, since you're allowed to use this calculator, literally you could kind of just guess and check till you get it. Just put this part in on the calculator. Here's how you use it. Use this for your cube root of 18 times 5 cube root of 6, and we know we need something equal to 23.8110157.8. And then we're just going to back this out. And we need 15 cube root of something. Okay, not 1. Try 2. Try 3. We're getting closer. Try 4. And I found a match, which means that x has to be 4. That's the answer. Okay, so as a math teacher, I kind of feel like I just cheated using the calculator, but you're allowed to use that calculator on the test, so that's one way to solve it. If you want to know the radical rules for solving that, the works looks something like this. Cubed root of 18. And how do you make 18? What times what makes 18? Maybe 2 times 9. And this 5 here, I'm going to move it to the front already. And the 6, I'm going to multiply it to. I'm going to put it right here. And I'm going to factor the 6 and the 9. I'm going to factor them down on the next line. 5 cube root of 2. And I know that 9 is 3 times 3. So I broke down the 9. And then to make the 6, what times 1 equals 6? I know that that's 3 times 2. And the reason why we wanted to factor everything down is because we've got a cube root. And so I wanted to find 3 of the same number. Now that I have these 3 3s, and it's a cube root, I can take this out and multiply the 3 times 5 cube root of 2 times 2 equals 3 times 5 is 15. Cube root of 2 times 2 is 4. So here's the way to solve this out by hand without the calculator. Over here is a way to solve it with a calculator, just to find the match. And this is on IXL, some really good practice. Lesson MDZ, very, very similar to this, simplifying radicals. And only 16% of students got this question right. So, I don't know if you want to go this way or if you want to go the calculator way. Whatever you got to do, get this question right. As long as you're, allowed to. And that answer was 4. And then question number 39 says, Margot surveys 150 high school juniors and seniors about their favorite types of dipping sauce. She records the results in the table shown. How many more high school juniors and seniors chose honey mustard sauce than sweet and sour sauce? So we want to see how many picked honey mustard. Why did I make that pink and not yellow? Oh, lost opportunity. And sweet and sour sauce. Juniors and seniors. So what do we need to do to solve this? I told my class today, I said this looks really familiar from like a 5th grade math question when I taught 5th grade. Honey mustard. How many juniors and seniors had honey mustard as their favorite? What would you do with those numbers? Add them up, right? 26 plus 22 makes 48 for honey mustard. And how many juniors and seniors like sweet and sour? 11 plus 12 makes 23. And then how many more chose honey mustard than sweet and sour? What do you got to do with the numbers? How many more is telling you to subtract? 48 minus 23, we get 25, and that is the correct answer. 25 more high school juniors and seniors chose honey mustard than sweet and sour sauce. And question number 39, I didn't really find any practice for this in the algebra section on IXL, but 68% of students got this question correct on their algebra EOC last year. So that's good news that you should hopefully have a question similar to this on your test. Okay, and next we have question number 40. Which says the graph of y equals f of x and a table of values for an exponential function y equals g of x are shown. Which statement correctly compares the graphs of the functions? And right away, they're saying like one of the functions will eventually be greater than one of the other functions. And that's usually a hint that they're telling you to like figure out what type of function each one is. And this one, they're showing you that you have what type of function would that be? Linear function, quadratic function, or exponential function. And when it's a straight line, it is linear. And then this g of x, they give you just a few points. Just graph them really quick. When x is negative 2, y is 0.25. That's about there. When x is negative 1, y is 0.5. Just slightly higher. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. So it's going like this. And what type of function has this curve like this? Is that linear, quadratic, or exponential? This type of curve is going to mean that this is exponential. And you can see that the curve is going up. And this is always a standard that is asked in Algebra 1 in Florida. And on all of the practice test questions that I've seen, they're looking for you to get to this realization that every exponential function, the y values are going to wind up being much higher than the y values on the linear function. So as the x values increase, g of x, the exponential function, will be greater than f of x, the linear function. And that's our answer here. And for question number 40, there goes my Ray dog. Sorry about that. We do have some practice in IXL. We have lesson GD7, and 40% of students got this question right. I'll be back in just a minute. Okay, sorry about that. Okay, so that was question number 40. And moving forward to question number 41. Sanjay buys X boxes of hot wings and Y bottles of soda for a party. The numbers of boxes of hot wings and bottles of soda he can buy with $40 can be represented with the inequality shown. Which graph represents all possible solutions for X and Y? First of all, looking at our inequality, since we have the line underneath, it says 40 is greater than or equal to. Should that be the solid line or the dotted line? Anytime you have these, your graph gets the solid line. When it's just greater than or less than, your graph gets a dotted line. We made this note in our class. So since we have the or equal to, the dotted lines are out. And would we want, let's see, if we solved for either intercept, since we are in standard form, if we try to find our, let's say, our x-intercept. So what is x when y is 0? So put in a 0 for the y. 40 is greater than or equal to 6x plus 2 times 0. 2 times 0 is 0, so that cancels to 0. Divide both sides by 6 to get a 1 here. 1x is greater than or equal to 40 divided by 6 is 6 point something is greater than or equal to x. I'm going to turn it around and say x is less than or equal to 6 point whatever, doesn't matter. And we can see here we want the x values that's less than 6 to be shaded, not the x values that's greater than 6. So this one's wrong, and answer choice A is correct here. And you can find some practice for this in IXL on lesson N9W. And we also in class, we did lesson HHP is another one. Only 32% of students got this question correct. So, not sure why that wasn't a little bit of a higher percent. Maybe this is a more difficult question, but if you've got multiple choice like this, I would hope the percent would be higher. All right, and then just a couple more to go, guys. Number 42 says Janelle buys blackberries and raspberries to make pies. Blackberries cost $8 per pound. Raspberries cost $9 per pound. Janelle can spend a maximum of $40. Create an inequality to represent how many pounds of blackberries B and raspberries are. Janelle can buy. All right. Janelle buys blackberries and raspberries. Blackberries cost $8 per pound. Raspberries $9 per pound. A maximum of $40. So the most she can spend is $40. Would we give that less than, greater than? Oh. Less than, greater than, less than or equal to, or greater than or equal to. Which inequality does it get? The maximum of $40, right? Is she allowed to spend 40? Could it be equal to 40? Yes. So these are out. And is she spending less than 40, or is she spending greater than 40 if she can spend a maximum of 40? She's spending less than 40. So there's our sign. That part's taken care of. And blackberries cost $8 per pound. Raspberries cost $9 per pound. And what do you do with the amount of money she spends on blackberries and raspberries to see how much she spent on both things? You add them up. And we're already done. We have created our inequality. 8b plus 9r is less than or equal to 40. And you could have that flipped around. You could have had the 40 first. $40 is greater than or equal to 8b plus 9r. Either way, you would be correct, and these could be flipped around also. Any way you enter it. You can practice this in IXL on lesson Z, A, Y. And 25% of students got this question correct on their test. Okay, so I'll put that in. 8b plus 9r is less than or equal to $40. And then question number 43 says, Cynthia buys some tools. She creates exponential function v to predict the value of her tools after t amount of years. She predicts her tools will have a value of $380 after 1 year and a value of $361 after 2 years. So, I know on an exponential function that, right here, I'm looking here on the reference sheet, that this letter A in the exponential function is, excuse me, that's the y-intercept when x equals 0. So if I want the value at 1 year to be $380, I don't want it to be $380 at 0 years. So I know these two are out right away. And I don't know if you noticed, but as soon as I kind of saw this question, I started making my calculator bigger because I'm going to put this in the calculator. Let's try answer choice A. 400, 1 minus 0.05 to the power of t, which is like our x, right? And at 1 year, we want it to be 380, and it is. And at 2 years, it needs to be 361, and it is. So answer choice A, it works for this question. And let's, just for our curiosity, if we tried answer choice B, that has a 389, and this has a 0.19, yeah. When a t is 2, we do not get 361. And when t is 1, we don't get 380. So that didn't work for either of them. So A was the correct answer, and just being able to practice putting this in the calculator will help you to check your answer for this type of exponential function from a word problem. And you can practice this in IXL, lesson LZW, and only 14% of students got this question right. So I really think that if you practice putting these in on the calculator and trying out the numbers, like if you're practicing, you can beat that. Excuse me. So that was A. And then question number 44. The graph of a quadratic function is shown. Which equation represents the function? And right here, this form of quadratic function on the reference sheet, you see I keep going back and looking at the reference sheet, and it helps to get my memory to remember what these things are called. So this one, the second one here, is called vertex form of a quadratic function. So I'm going to write down the formula. And you would need to memorize the name of that. That's vertex form of a quadratic function is f of x or y, however you want to call it. Y equals a times x minus h squared plus k, where hk is your vertex. That's something to memorize. And what are the coordinates of our vertex? Where is the vertex? It's here at the maximum, the top, where x is -3 and y is 4. So for h, it would be minus a -3, so it would be x plus 3. All three of these have x plus 3. And then y, your k, is 4 plus 4. You're out, in. Okay, so from the vertex, we've got that. And then, like we said on the other quadratic function question, this letter A tells you whether your quadratic function goes up like this or upside down like this. And when it's negative, when this letter A is negative, we have this type of shape that has a maximum. And that's what we have here. We have a maximum. So we need our A to be a negative. So this -2 works, and this is positive, so that doesn't work. So A has to be our answer to question number 44. And you can also check a couple more points on the calculator and make sure that they work. -2 times x plus 3 squared plus 4. And then we said when x was -3, y is 4. And that's what we got. Another point, when x is -2, y is 2. When x is -2, y is 2. When x is -1, y is -4. And that's what we got. So we know for sure we got the right answer by knowing how to read vertex form of a quadratic function, or by plugging it on the calculator. If you try the other points for x and y, they're not going to work out for all of the points. So that's another way to check. Number 44. We do have some practice for this in IXL. It's lesson C7T is pretty similar to this. And 42% of students got this question right. And now we are moving on to the very last question on this practice test, question number 45, which says, select all the values that are equivalent to the square root of 24 over the square root of 8. And right away, I'm going to my calculator. Square root of 24 over the square root of 8. I get 1.7320508088. And then you can just check them all. Do they match this? Square root of 3, 1.7302050808. Match on the calculator. 1 over square root of 3. Not a match. Square root of 16. Not a match. 2 square root of 6 over 2 square root of 2, 1.73050808. Match. And then we got 4 square root of 6 over the square root of 8. Not a match. So the calculator can give you that answer. You also, if you know your radical rules, you can do this by hand. Square root of 24 over the square root of 8. One way to go about it is just a big old square root. 24 over 8. What is 24 divided by 8? That's square root of 3. That's where this one came from. Another way to go is to find two of the same number in here. So square root of 24. 24 can be written as 2 times 12. 8 can be written as 2 times 4. And keep breaking down my factors. On the numerator, 12 can be broken down to 2 times 6 over square root of 2 times 4 can be broken down to 2 times 2. Take out these two 2's and move them to the front, and you're left with the 6 inside. Take out 2 of these 2's, move them to the front since it's square root, and then you're left with the 2 inside. So that's a way to do it by using the radical rules. And there is some practice of this in IXL lesson ZFF. And only 15% of students got this question right. I think if you get comfortable using this calculator, we can get more of our students to get this type of question right. I hope that this practice has been helpful to you if you've made it this far. I'm really, really hoping that you do well on your test, whether you're taking it tomorrow, like I know some of my students recording today and they're going to be watching this tonight for their test tomorrow. I hope that you guys pass your test. If it's not your first time taking it, I hope that this time that you take it that you definitely pass, or you at least improve your score and figure out which topics you need some more practice in so that you can pass this algebra EOC to meet your math testing requirement for graduation. So this is Mrs. Cameron, and I am rooting for you. I will catch you guys the next time we are studying for some math.